Welcome to this training video. In this training video, I will provide overview on communication systems and networking. In this particular training video, I will talk about mobile technology and mobile communication systems. By the way, this is Said. I provide consultancy service under Just Etc. Technologies. This is my company website, and this is my personal profile, and this is my email address. For address, so I provide training videos in these websites in Bengali language and in English. If you have any concerns on questions on computing in areas in any area, you can provide a question here. You can also answer other people's questions. Anyway, so these are the services I provide consultancy on: software development, web development, software engineering, software information architecture, mobile development, and business analysis. Anyway, mobile communication. What is mobile communication, or what is mobile telephone system? I think in mobile communication, information, data, picture, voice, all these are communicated. All these are transferred between two or more mobile devices, or between one mobile device and one standalone device. Also, one phone also communicates with the base stations. Also, base stations communicates with each other or with the switching center. So, yeah, the main concept is some units in the communication system will be mobile, and data and information will be transferred between mobile or standalone devices, and there are some other stuff involved, just like base stations and switching centers, all those things. Concept of cellular network. The mobile telephone system, they work based on cellular networks. So how does a cellular network work? In the cellular network provider services or mobile communication service provider company divides his coverage area in the area in which he can provide the service. He divides the coverage area into smaller areas. Each of those areas are known as cells. In each cell, there is usually one base station with usually one antenna. It's a small office with one antenna called base station. And base stations are controlled from a mobile switching center. The mobile switching center controls call connecting calls, records the call information, how much time, source and destination, what type of service, is there an SMS, MMS, quality of service, or whatever information about the call. And also, switching center also has some computerized billing system that generates billing information, billing data based on the users. And cellular networks, they use radio frequency for communications, and each of the cells, they can be hexagonal type, square, circular, or of any irregular shape. And for each cell, a range of radio frequency is allocated. Then what happens is that mobile company, they will divide their coverage area into each cell, and each company is given a range of radio frequency, and it will divide those radio frequency and assign a range of that radio frequency into a cell. For each of the cell, it will assign a range of radio frequency. I think the radio frequencies can overlap the same radio frequency range. It can be used in another cell, but one thing that has to be remembered, that you cannot use the same radio frequency range in the neighboring cells. It can be used in a distance cell. And the mobile data communication, it uses some sort of encoding. I think the voice or data you try to transfer through the cellular network, they get transferred or encoded into another form so that they can pass by the air or the wireless media appropriately, and also you have to make sure that there is no interference in between, because in the same cells there will be many users using the same company and same frequency range. So yeah, you have to encode the data so that there is no interference, and also it has to be reached in a good condition so that the receiver can decode and understand the information of the voice or regenerate the voice. Anyway, some encoding methods are FDMA, CDMA, PDMA, and TDMA. FDMA, frequency division multiple access, CDMA, code division multiple access, TDMA, time division multiple access. Usually cellular network for most of the times, or for majority of the companies, use frequency division multiple access. It requires that the neighboring cells use different frequency range. In FDMA, as I told, that the company divides its frequency range and uses a particular frequency range for a cell, and within that frequency range it is further subdivided into channels in smaller frequency range. Each of these channels are assigned to a mobile unit or handset. So that the signals from different handsets don't overlap or don't interfere. And okay, I think we will come to the details. In code division multiple access, in this case the signals are encoded with some sort of code. So still, if two messages can be transmitted within the same frequency, but as they will be encoded with different code, they will not interfere and they will be still retrievable. We can consider CDMA like this, that in a single room, two peoples are talking using one language, another two people is using another language, another two people is using another language. Still, if their voice at the same sound level, but still they will understand their partner. It will not get mixed. CDMA is that kind of technology. And time division multiple access, it is actually used in conjunction with FDMA or CDMA. And TDMA cannot be used, or neighboring cells cannot use TDMA or cannot create the cell concept. Actually, what happens is in FDMA or CDMA, TDMA is used in the channel, in the CDMA channel on the FDMA channel, to create further channels on it. In this link, you can see the pure FDMA, how it works, and the old analog telephone system, how they used FDMA. And here you can get some overall understanding of those technologies. Okay, actually right at this moment I don't have the internet connection, so I cannot show this. Okay. Okay, here we can just see a little bit about the mobile unit, the mobile handset. In the mobile handset, the main components: one control unit, one transceiver, and one antenna system. Control unit, it coordinates everything, controls all the other units, activates, deactivates different parts as required. Transceiver transmits signal and receives signal. Antenna transmits transmission happens with the antenna system, and receiving also happens with the antenna system. Other components, a battery, keypad or touchpad, touch screen. In GSM system, we have SIM. In CDMA system, we have RUIM. And each mobile device can be identified with the IMEI number. This is for GSM, W, CDMA, IDEN, and some satellite phone device uses IMEI. Okay, phone technologies. Two different types, GSM and CDMA. Global System for Mobile Communications and Code Division Multiple Access, GSM. GSM is currently at third generation of mobile. We'll see the different generations just after a little while. Third generation of GSM, it is known as UMTS, Universal Mobile Telecommunication System. In Bangladesh, Grameenphone, Banglalink, Teletalk, and Airtel, they use GSM. The GSM uses frequency division multiple access with TDMA. To TDMA just to create more channels. In FDMA, the number of channel is 124. Each channel is 200 kilohertz. Uplink and downlink both can be this. And duplex separation, I think it's just the sending and receiving. This separation is 45 megahertz. If we use TDMA with FDMA to create more channels, we can create 8 time slots. GSM technology worked on improving TDMA just to provide a better mobile radio station, provide better mobile radio service. GSM uses for frequency range, GSM 400, GSM 900, GSM 1800, GSM 1900. The advantage of GSM as of now, roaming, and it can provide international roaming. The mobile phone set, they can use frequency hopping. If signal is not good at one frequency, it can hop to the next frequency. It can provide high quality continuous connectivity, GPRS and edge facility. These are actually high speed data transfer service. SIMs are easy to use, high quality digital voice. They can provide SMS service and MMS service. Use MMS service, you can attach files and pictures. GSM is the most popular cellular phone technology used in around 218 countries. And it can support integrate third generation of mobile technologies as of now. Provide secure communications. It can provide secure communications. Disadvantages of GSM. There are some interference and comparatively high electricity consumption. That means battery life is not much. Maximum cell size can be 120 kilometers. Previously it was 35 kilometers. Code division multiple access, another phone technology, cell phone technology. It was invented by Qualcomm and it got widespread in 1995. With CDMA, data can be sent with the same frequency but with a different code or encoding for each message. So they are still different. CDMA started at second generation of mobile technology. On the first generation, there was no CDMA. So on 1999, CDMA became or improved to third generation technology and known as wideband CDMA. In CDMA, each receiver has a unique code and it tries to identify the message with encoded with that code. Messages with any other code are regarded as noise. Advantage of CDMA, very low radiation, low transmission power, battery life is usually longer. GSM power consumption is 600 milliwatt to 2 watt, but in CDMA maximum 200 milliwatt. CDMA can use advanced soft switching, so no specific hardware for switching, less noise, high quality of voice. With the same bandwidth, same frequency range, CDMA can provide 4 or 5 times more channels or more devices than GSM. Disadvantages of GSM, actually it will be disadvantages of CDMA. There is a mistake. Roaming is limited because not many service providers are there. Need to use a special phone set, less popular. With increased number of users, call quality decreases. Within the same cell, with increased number of users, call quality will decrease. Now the different generations of mobile phone technology or mobile communication system. Actually, how this mobile communication technology evolved over time. So first generation on 1983. So in North America, there was the advanced mobile phone system that is in the first generation, and they used analog signal to transfer voice. They use FDMA to separate channels. There is no TDMA to create further channels inside FDMA. TDMA is actually digital technology. So at this point there is only analog. 2 analog channels are used: forward, this is base to mobile; reverse, mobile to base. I think during the call, if sender or receiver, if someone moves, the call got disconnected. So still it's using wireless medium and those things, cell phone technology, but the movement was not allowed much. And the phone units, they started to use microprocessors and semiconductors. Signal frequency comparatively low. Some examples are AMPS, NMT, NORDI, Total Access Communication System, CT1. Second generation, I think when mobile technology got into second generation, it improved first generation by removing noise from the voice. It initiated the noise removal from voice. It can transmit voice using digital technologies, just like TDMA. AMPS, it became second generation AMPS, and it uses the D AMPS. DMPs started to use TDMA with FDMA to create further channels and to transmit digital, and just started to use digital technologies. CDMA was invented at this generation. Some examples are all these: TMPS, CT2S, 136, GSM, PDC. These can be different technologies used in different countries or different carriers in the same country. You can say IS-95 and CDMA1, they are CDMA technology based second generation. So second generation, as I told, start to use digital radio signals because semiconductor and microwave technology got improved at this period. Digital modulation is used, faster transfer of data, improved data security, prepaid service got started, limited international roaming. I think on first generation the roaming was not allowed and the movement was also not allowed. Packet switching network for data communication, port switching network for voice call, SMS service and MMS service, both data and voice can be transmitted. Can be interfered with other carriers. Call does not get disconnected if the people move. Some examples are this. Third generation, I think the idea started on 1992. The ITU, Internet Communication Unit, got established to improve the mobile phone technologies. So the plan for third generation was voice quality should be similar to the telephone system. Data transfer speed should be in the running cars 144 kilobit per second, while walking 384 kilobit per second, at home 2 megabit per second. Bandwidth is 2 megahertz, and it also provides the internet connectivity. So internet connectivity started as that third generation. On 2001, Docomo in Japan started third generation mobile system for the first time. CDMA with wideband technology became third generation in 1999. WCDMA, it is called EMTS. High-speed data transfer and use of multimedia data started. On third generation, high-speed packet access got implemented in this generation. Data transfer can use both packet switching and circuit switching. Using packet switching, third generation can provide fast data and picture transfer. Mobile phone can use now internet and data transfer. And already told, EH helps to transfer more data. High-speed data transfer more than 2 Mbps. So third generation, mobile banking and mobile e-commerce got started. Some examples are GSM, EH, EMTS, CDMA 2000. These are the third generation technologies. Radio frequency. These are the technologies for radio frequency and channel access to create multiple channels. This is actually TDMA technology, just improved. The features for third generation mobile phone, they can use to listen to music, to watch TV, cinemas, download from the internet, music download, internet browsing, internet gaming, game download, video conferencing, all-time connectivity to internet. They are the features of mobile phone set of third generation, different methods to pay bills, paper bill, paper station flat rate. These are the examples. Fourth generation, this is the technology for the future. The concept is using IP-based switching instead of circuit switching or packet switching. Ultra broadband internet in mobile system. The idea is to have ultra broadband internet in mobile system. And fourth generation, running device speed 100 Mbps, standalone device speed 1 gigabit per second. In third generation, the target was 2 Mbps, 144 kilobit per second, 384 kbps. On fourth generation, the target is running device 100 Mbps, standalone device 1 gigabit per second. And fourth generation, mobile phone technologies will be used for mobile web access, IP telephony, gaming services, high definition mobile television, video conferencing, 3D television. Many of the services are available in third generation, but not in improved form. These will be improved with more speed and three-dimensional technologies. Okay, LTE long-term evolution is also a fourth generation system that can provide 326 megabit per second peak bit rate data transfer. Actually, LTE can use WiMAX or flash OFDM. It's just optical technology. Okay, they can provide broadband wireless speed to 33 Mbps for mobile users. I think is WiMAX and flash OFDM. They can provide this. They fall into the fourth generation of mobile technologies. So if you have any question, post your concerns at ask.justitc.net, and if you can answer some of the concerns, please also answer. So this will be all for now, and thank you and have a good day. That's all for now. Thanks.